Hi, today we're going over section 4.2, multiplying and dividing rational expressions. In this video, we'll go over problem number 4 and problem number 5. Notice we're dividing two rational expressions. So the first idea is to keep, change, flip. I'll write my first fraction x squared plus 2x over 5 plus x. I will change the sign to multiply and take the reciprocal of the next fraction. So 3x minus 6 over 4 minus x squared. Next, I need to factor out the GCF and simplify wherever I can. Notice in the top, I have x squared plus 2x, so I can factor out an x and get x plus 2. We also see that we can factor out a 3 in this other numerator, so this would give us 3 times x minus 2, and I don't see any other GCF, so we continue to use our factoring rules. So the numerators would be x times x plus 2 times 3 times x minus 2. In the denominator, I have 5 plus x. I can consider that one binomial and put it in parentheses. And here I have the difference of squares. So 2 plus x times 2 minus x. Okay, this says x plus 2. This says 2 plus x. Is that the same thing? Yes, both are positive. So now I can divide like terms, and there's a like term. What about x minus 2 and 2 minus x? Is that the same thing? No. Can I make it the same thing? The only way to make something the same thing in this case would be factor out a negative 1. Will that help me? Let's see. What if I factored out a negative 1? Then this would be negative 2 plus x. And since it's commutative, addition is commutative, I could rewrite that as x minus 2. There you go. So factoring out a negative 1 is another little fun trick when you're trying to simplify rational expressions. So now the x minus 2 and x minus 2 does divide to 1. And let's see what we're left with. In the numerator, I have 3x. In the denominator, I have negative, and then 5 plus x. And that is your problem simplified. Now let's go over problem number 5. Step 1 is to rewrite it. So 5x plus 15 over x squared minus x minus 20, and then multiply, change that divide sign to multiply, and take the reciprocal. So flip the fraction, so x squared minus 16 divided by x squared minus x minus 12. Then I take out the GCF and factor each of the 4 pieces, both numerators and both denominators. The first numerator I can factor out a 5, and I'm left with x plus 3. No other pieces have a GCF, so I continue with my pattern. The first piece is 5 times x plus 3. The next numerator is the difference of squares, so x plus 4 times x minus 4. Then I look at the denominators. 2 trinomials. So I have this template of the 2 binomials. So I know that x is the first piece. And I need 2 numbers that multiply to give me negative 20 and add to give me negative 1. Since it multiplies to give you negative 20, you need one of each sign. And then the 5 will be the bigger pile. So plus 4 and minus 5. When you multiply them, they give you negative 20, and you add them, they give you negative 1. Now we look at the final denominator and set up our template again. We know that it starts with x. We know that our sign here is negative, so one of each sign in the template. And 12 is 3 times 4. So a negative 4 and a positive 3 will add to give you negative 1, and we're set. Now you can go through and divide. I have a common x plus 4, so that divides to 1. The x plus 3 and x plus 3 also divides to 1. Anything over itself is 1. And then also the x minus 4s divide to 1. And that's awesome. Let's look at what we have left. In the numerator, we have 5 times 1, which is 5, and then over x minus 5. Now, should we just divide the 5s? No, you cannot divide unless you're multiplying. Notice this minus 5, you're subtracting the 5. You cannot divide those 5s. Very common error. Don't let that be you. I hope this helps. See you next time.